All right, next up, I want to bring on Illia from Near to have a conversation about crypto and AI. Please give Illia a big round of applause. Welcome back.
Thank you.
Um, there's a lot of things I want to touch on and talk about, and this kind of jumps in from your knowledge about AI from crypto and before, when it was a lot more small and a lot more creative as an industry. Actually, still creative now. But the thing I want to start off by asking you is, from your perspective, like, what's the actual natural overlap of crypto and AI?
Yeah, so there are a few different aspects, right, where it makes sense. I think for crypto, AI brings a lot of simplification, right? You can, like right now, in a lot of cases, you as a user need to figure out all the details of how to get things done, where to find things. Is the asset you're trading a real asset or just a fork of a fork of a fork? Um, what information is going on, why the reason, right? I mean, and we see this right now, kind of, you have, CoinMarketCap AI that like gives you some information about the thing you're looking at and why maybe it moved. You have some assistants where you can start talking, but obviously, this is going to continue evolving and improving. And so this is general pattern across not just crypto, but the whole web, internet, computing. We're going to change how we interact with computing to be more AI-driven. Not always natural language. I think this is also like, people think, oh, it's going to be chatbots. No, it's not going to be chatbot. AI can predict what you want and actually have a generated UI with exact information you want that you just need to click on, right?
So when you say that, are we kind of defining the reliance on AI as a faster way to get an answer to a question, or is there a different metric here?
So I would say there's effectively two routes. One is you express intent, right? So and you get to the action, not always the answer, but to action. And the other way actually it predicts which actions you want to take, and you just need to authorize, or it does it for you even at all, right? So like the experience that we will have is not going to be you need
So
to
specifically
ask
the prediction and not the execution. Is that what we're also measuring, or are we counting both?
both, yeah. So prediction and action, both.
So that makes sense. I agree. We're going to see a lot more of that. How do we account for reliability on the execution of that intent?
That's a great question, and there's a lot of kind of issues there. So what are the potential issues? One is, and this goes to like, what are the issues now AI has, right? The reliability is a general AI problem.
Compounded.
Yeah, compounded issues. You have obviously, malicious vulnerabilities that are injected into either AI model training or into like agentic code around that. You have obviously data privacy leakage, people training on data they shouldn't, etc. You have an interesting trust problem where if I'm a model developer, I'm don't trust like generally other compute providers because they may steal my weights. And so I generally, I have a contract with Amazon or, OpenAI with Microsoft and kind of use their compute or build own compute. But there's like a trust issue, which, we're kind of in a space.
I think we know a little bit about that.
Yeah, we may know about that. There is just generally like a sovereignty problem. So if you're sitting outside of, let's say, US, where, most of the models are built and you're kind of thinking about it, hey, our government will use more AI, our companies will use more AI, and now this other third country can effectively decide on what and how we can use it and what decisions it's going to make based on whatever training data. So like there's a fundamental sovereignty problem.
Bias a whole nation.
Yeah, bias the whole nation into some direction or just turn it off. Imagine just like, let's say some country decides to use, let's say, OpenAI for their government operations, and OpenAI can just like, we'll turn it off. It's like, the amount of power.
We found the new equivalent of disabling the internet in a conflict region.
Yeah. So this is kind of, and this is, if you project it, obviously, if like one company wins kind of the AI race, we effectively ending up somewhere between AOL, internet, and 1984 Big Brother world, right? Because effectively every single interaction will be facilitated by one company, and then it will drive how you make decisions and what information you see kind of on day to day. So those are all things where crypto and more broadly blockchain kind of decentralized technologies, have some answers and solutions for, but they need to be built for this kind of AI problems.
So what's the nuance here? Like, what do we need to build for? And is there a difference between building a specialized blockchain that is designed for this, or is it that we need to make our crypto networks more compatible with how LLMs are kind of operating so that they can talk to each other a lot more easily?
So it's more of a kind of, again, if we're solving AI problems, we need to think from AI first perspective and kind of build the stack for that, right? Well, AI is about compute, hardware, kind of models, inference, then you go into like application stack, and then you go into like, agentic and all the other spaces, right? So, well, if we want to have kind of no centralization on kind of compute side, right, we need to figure out how to decentralize compute. Well, the biggest challenge we've had is that blockchains are, way too expensive in their execution. ZK is expensive. Also, we don't have any privacy in the current state, so we need some way of doing compute that is private and effectively doesn't add much overhead. Well, it wasn't really possible until last year, but now with Nvidia, you can actually have a confidential computing mode.
Sorry, what changed last year? Just confidential computing?
So yeah, Hoppers and Blackwells now have confidential computing. Intel and
the new Nvidia chips. I see.
Yeah, ARM has this new TDX mode, which is like at least easier to program and run arbitrary software instead of previous generation. Supposedly have also less issues, but obviously the important part, the trade-offs here are very different because you are running AI models and not kind of relying on purely that for like financial transactions. But this enables to have now confidential and to some extent verifiable computing that has very little overhead. So we've benchmarked it, and it's 1 to 10% depending on the kind of RAM usage, etc.
So, kind of tying that back in, it provides us slightly better guarantees around people not abusing the information. But does that mean we now need to change up how we're building current smart contract platforms, or how do you actually make that more practical with this blockchain and LLM integration, or just any AI model agentic integration?
Yeah, so now you can bring these things together, right? You can actually run I call it the brains in this secure enclaves, and then the muscle is
So you
on
think
chain.
securely, but everything else could be
Yeah, but you execute on chain, and you can verify also that your brain is not going crazy, right? To use an analogy. And so you can have this kind of coupling where all the certificates, everything of the secure enclaves are verified on chain. It's really easy to do that. And now you can, again, so we have this mindshare agent, which was given $10,000. And so what it does, it reads Twitter and analyzes for sentiment of different assets. And then it prepares effectively through our multi-chain intent trading platform a portfolio and rebalances based on the change of sentiment. And so it made
how's the performance been?
4,000, so 40% up in 2 months.
That's pretty good.
Yeah, not financial advice.
So,
but you can imagine this, like expanding this, and this is going to kind of broader sense. Like this actually enables effectively autonomous agents, right? Right now, everything in kind of both in Web 2 and in Web 3 to some extent, it just runs on somebody's machine, right? It's just, you can turn off that machine and that agent stops running. Well, now here you can actually run in this kind of decentralized T cloud, and you can, whatever machine you turn off, there's always another machine that can run exactly the same code. It runs off the same state, and it can, holds assets. So now you have autonomous agents, which are effectively unstoppable. You can have, some governance with tokens, etc., over them. And then they actually can start doing business. They can potentially go raise money through a token and acquire a gas station or a laundromat and, run it. Now, we're probably still a bit away from that, but this is kind of the idea where, okay, how do we give agents a way to actually participate in commerce, both on chain but also off chain? Well, they need a new way of effectively legal contracts, arbitration, like all of these instruments that we traditionally have in commerce. Like normally, I'm sponsoring this event, you send me a contract, I need to sign it, and my lawyers check it, then wires, etc., money, etc. Like all of this is decoupled, and it's like very complex for. I mean, it's solvable with AIs, but when we go to kind of this autonomous.
Well, everything that's not real-world compliance is, in a way, because you still represent yourself as an entity if you were doing something that touches real world, but payments 100% make sense.
Yeah.
But I guess that the thing I'm trying to understand is, it seems like the bet you're making is that, great, we can get some better guarantees on computation if it's in a TE or a more secure computer environment, but we're just hoping that if you just wait long enough, things will be as performant and as
So that's what I'm saying. They're pretty much very similar performance, well, in TE.
Including the GPU advantage.
Yeah, so that's what I'm saying. 1 to 10%, and like mostly it's 1% overhead.
Oh, over? I thought you meant 1% of performance
No,
of
no,
the
1%
the
to 10% overhead. Yeah.
That's actually pretty good.
Yeah, I know.
Okay. Today I learned. This is amazing.
Solved. Okay.
Solved. All right, we're done. Okay, so does that mean we have to still change the networks in terms of how we design blockchains, or?
I think we'll start actually changing over time. I don't think we need to like change a lot.
I feel like what you described can be replicated as a smart contract or slightly better execution environment on top of existing chains. Is that a good way to think about it?
So you can call from existing chain. You can call into this. Let's call it a coprocessor.
Black box.
Coprocessor.
Right. Well, we'll go back to 2022.
Intelligent coprocessor, right? I mean, but this is what rollups are. Rollups are the same thing.
Well, yes. This is not. This is not our. This is being recorded, so we'll not go back to how we usually.
But yeah, I mean, it's effectively intelligent coprocessor that you can run, and then you can verify that whatever decisions, outcomes it did are validated. And then, but yeah, from a blockchain side, you need to like integrate it tightly, so all the verification, everything is like done very easily. Now, over time, I think if we want privacy, we probably need to start moving our blockchain itself into TEs and like start like.
But all this still assumes that we're just giving a secure compute environment. We're not actually doing things with like encrypted information being acted on or being modified.
We do. So.
Is it to still then solve for like anywhere from RAG to just other context setting and having a notion of memory that is more readable? So you're kind of feels like, if I'm understanding this right, the constraint is still do everything in a box that guarantees no tampering, but the process remains the same.
So it guarantees no tampering and it guarantees confidentiality, right?
Confidentiality of what? Compute or something else?
Confidential compute.
But not the data itself.
And the data is encrypted for that specific box when you send it. So you have a TLS connection with that specific box, you encrypt it with a TLS certificate, it's only decryptable there. And then on top, so the next primitive that on near we have is called chain signatures. So chain signatures allow to effectively have a programmable encryption decryption. And so you can actually attach to a near account or to a specific Docker container that will run in TE a way to recover a decryption key. And so that's
awesome.
Have an encryption key. So you can have encrypted data per account or per instance of the agent that is only accessible inside TE. And so now you can actually have a private memory, you can have private state that you can act upon.
And this is just like traditional encryption, not.
Yeah, this is MPC-based encryption, decryption.
So you
MPC
have
itself runs in TE.
A good context here for the size. Okay.
Yeah, so now you're solving an interesting problem that, again, in AI right now, your context is effectively, part of it is in OpenAI, part of it is in Anthropic, part of it is in Gmail, like it's all separated. And so you can actually take all of this context, put it in an encrypted way under your near account, and then give it access to it to different applications that also run inside TE, so they're not leaking your data. Right, so you're starting to solve actual problems for people.
So you're giving everybody like their personal memory box, and they can attach it.
Yeah, and then you can bring models to it instead of giving your data to the model.
That's going to be an awesome world. So is something like this possible on Near right now in terms of?
This should be like launching in the next coming months.
And how do you kind of think about just overall intents for payments with a lot of the agents coming into play?
Yeah, so intents for payments is effectively this new way of how you can actually do legal contracts, right? So the way intents work is effectively you say, hey, I want this to be done, right? So you describe effectively your intent, which can be in natural language, can be in kind of structured format, and then you have other participants who say, hey, I will do it in this way. So when you pair these two things up, you effectively create a contract, which can say, if we don't agree on outcome, we will use this arbitration, which can be also AI. This is like Shriram loves to talk about that. And then if not, we can also use this actually court system in Commonwealth or in the specific jurisdiction. And so when we agree on that, this effectively settles, and so then it can be executed and kind of adjudicated as needed. The simplest use case of that is trading, obviously, because the adjudication is very easy. Did the funds arrive or not? But the more interesting use cases, so we already had in fiat, you can add like other real world assets, but more interesting is actually starting to add work, right? So I want this
Adding
to
what?
be done.
Like work as a general asks.
Yeah, yeah. I want this to be done. I want a tree to be planted. I want website to be built. I want this analysis to be done. And you can have AI agents now coming in and saying, cool, I'll do it. Let's settle on that. And then if you have a guarantee that this AI agent runs inside a secure enclave, you can now give it more context and more data and more access even to actually act on your behalf potentially.
How far is that from a pitch to reality?
I mean, we have a MVP for like coding to start.
So actually, maybe a higher level question. How much of being able to program something like this is specific to programming on Near versus me taking some Python SDK out of the box and not having to do too much tampering and come up with a new system or a framework to play with this?
So the agent itself, you can build in Python SDK, right, LangChain or whatever, right? That's not the pieces that you need is the effectively interfaces, right? One interface is how the agents talk to each other. So in normal AI right now, when people talk about agents, they usually consider agents running on their computer, right? But that's not when you want something to be done, right?
That's not always running. That's
you usually hire somebody
push
else.
or pull based.
Right, and so you need a protocol how like a person or an agent will talk to another agent who runs on their own behalf, like across trust zones, and so kind of that's not really a thing in normal AI space, but this is very much a thing in crypto where we always work across trust zones. And so we have this agent interaction transaction protocol, which effectively AITP as an HTTP for AI. And so that's kind of designed for effectively this interface. Now, it has blockchain components in it to have this intent settlement, signatures, etc. But it's not a blockchain
This
protocol.
is just a communication protocol.
It's a communication protocol. It works over different transport layers, and you can exchange structured information, you can share things, you can request things, etc. So it's a lot of just pieces that you use the blockchain and Web3 mindset, and then you kind of bring all of this together. Maybe we're building Web 4. Let's just
let's let 3 settle first.
finish the Web 3.
Yeah, I think we're still 2.5 from whatever. I think you said something at the beginning, which I want to come back to, but you kind of said that ultimately you don't believe we're going to have interfaces in the future.
Yes.
How far of a future is that? And I guess more concretely, what do you think there will be interfaces for?
Well, sorry, I don't believe we're going to have websites and applications.
So what does that mean? So what will we get a example experience for some application that I guess people have, or some things that people need to use?
You just have your assistant, AI assistant running on your devices, across all your devices, and it will, when it thinks it needs to show you some user interface, it will show you that user interface.
Oh, so it's just in time versus like not.
Yeah. I mean, it would have a cache of components, right, and plug it in. Like this is actually the whole. I mean, back 2-3 years ago, we were building this blockchain operating system. This was designed for that vision where we just started with humans building components, but so we can train AI to generate components. But this is, I mean, we already see this happening, right? Like you can vibe code your own applications.
You're right. Yeah.
And you can imagine if you have all the APIs and services, like one of the problems.
Looks like time's up.
This fireside chat is fire.
En raison d'un incident technique dans notre bâtiment, nous vous prions d'évacuer les locaux. Souhaitez-vous rendre aux portes de sortie de secours?
Time to
Attention,
exit.
attention. Because of a
I
technical
should have paid more
difficulty,
attention in my French
we
class.
ask you to evacuate the premises. Please go to the emergency exit.
Okay.